So this entire time, right, every time we talk about sine, cosine, tangent, or cosecant, secant, or cotangent, we were always, you could always kind of make those work back into a right triangle, right? We had to kind of stipulate we were working with right triangles. But there are ways to be able to use trigonometry, the trig functions, in non-right triangles. Okay, and this, like I said, is one of those things, the law of sines. So I'm just going to kind of show it to you here, and then, or show you what the relationship is, and then we'll kind of use it. It's pretty simple, pretty straightforward. I'm not going to show you kind of like where it comes from necessarily. I'm just going to show you the setup for it. So let's say we have a triangle. Okay, and I'm going to specifically kind of try and draw it so that it looks like it's not right. Okay, in other words, there's no right angles. Okay, here's a non-right triangle. Of course, the law of sines will work for a right triangle too. It works for all triangles, I guess, in Euclidean geometry. Okay, it works for all triangles in Euclidean geometry. All right, so I'm going to label this triangle here, just in kind of a particular way. So I'm going to name the vertices, or the angles, A, B, and C. Okay, and then we'll label the corresponding opposite sides, the lowercase version. So if this is angle A right here, then we'll label the opposite side lowercase a. And if this is angle C right here, we'll label this lowercase c, which looks exactly like an uppercase C, so hard to kind of distinguish there. But anyway, opposite angle B, lowercase b. Okay, so that's how we'll name our sides. Yes, I know in geometry you name your sides like side AC, or side AB, or side CB, but we're going to label them just with those single variable measures there. All right, and so here's the law of sines. It turns out that the ratio of the sine of A divided by side A, okay, so sine of angle A over side A, is the same ratio as the sine of angle B over side B is the same ratio as sine of angle C over side C. Okay? Or, and you don't have to write this one down if you don't want to, sometimes you'll see it written like this. Just, with the reciprocal. All right? That's it. That's the law of sines. Okay? The angle and opposite side, the sine of an angle and its opposite side in a triangle is equal to the sine of another angle and its opposite side, the same ratio. Okay. So let's just jump into an example. Okay, so let's solve for the missing pieces of the triangle below. Angle below. Okay. All right. So let's see here. Make sure I get this right. Okay. So I'll draw a triangle here. All right. And I'll label some things. So let's say this is like 97 degrees. Let's say this is like 40 degrees. And let's see that this is, let's say this is 22 here. Okay. And again, so here's the situation. All right. Now, you'll notice first of all that none of our angles are labeled like A, B, and C. So if you want to, you can, put some labels in here. We can put like the A, the B, and the C in there to kind of help us out, just kind of orient things. Okay. It doesn't really matter how you label things. All right. How you label it here. We're dealing with these non-right triangles. Okay. So, what are some missing pieces of this triangle that we can figure out without using trigonometry? Yeah, Alyssa, go ahead.
You can find the last angle.
The last angle. How?
By subtracting 40 and 97 from 180.
Exactly. So we can find that last angle, the missing angle right here, by just doing 180 minus 40 minus 97. Again, in Euclidean geometry, all three angles in the triangle have to add up to 180 degrees. Okay, so if we subtract those two things, we end up with 140, and then 140 minus 97, well, 43. That's what it should be, according to my notes here. All right, so you can label that in there. Okay, I don't know why I put parentheses around it. I guess that we solved for that. Okay. And that's actually really important. Okay, really important that we were able to find that, because when you use the law of sines, okay, when you use the law of sines, it's important that we start with an angle slash opposite side pair. Okay. And I'll try and show you what I mean by that here. So for example, if we didn't solve for the angle 43 here, so if we left that off, and we go back to what we started with right here, okay? Well then we could set up some different law of sines here. We could say the sine of b over 22 equals like the sine of 40 over a. But the problem with that, so I'll write that out here. Sine of b over 22 equals the sine of 40 degrees over a. But what's the problem with trying to solve an equation when we have it set up like this? What's the problem we run into here? Why can't we solve this with the way it's written? What do you run into? What's the problem? It's not a right triangle. Okay, but remember I said the law of sines. Law of sines does apply to non-right triangles. So we can use the law of sines here because it's not right. That's okay. Well, actually, law of sines applies to all triangles, not just non-right, all triangles. But what's the problem with trying to solve it here? Because it's more than one variable. Yes. Okay. So conceptually here, we have two variables in a single equation, two different variables in a single equation. You can't solve an equation when you have two variables, two unknowns, two different unknowns, like this. Okay. So, in other words, if we had not solved for that angle b first, we would have been stuck here with this one, and the same thing would also happen with c. It would just be sine of 97 over c equals then sine of 40 over a, or sine of b, which we didn't know, over 22. So it's imperative that we start with an angle and opposite side pair that we know. Okay? So in this case, we do know now that b is 43 and that the opposite is 22. So we can say sine of 43 degrees over 22 is equal to, and let's just go to the side A there and solve for that. So sine of 40 over A. Okay. All right. So now, how should we go about solving this? What should we do here? We have it set up, right? Sine of 43 over its opposite side, 22, is equal to sine of 40 over its opposite side, A. How do we solve something like this? What should we do? Yeah, Devin? Absolutely, yeah. It's a fraction and a fraction, or a ratio and a ratio. They're equal, so it's really a portion. And so, yeah, we can cross multiply here. And so you get A times the sine of 43 equals 22 sine of 40 degrees. Very good. Okay. All right, so then we can, now what should we do? This is finish solving here for A. To continue solving for A. Sorry, what should we do to both sides? Yeah? Divide both sides by sine of 43, you're right. So now we have A is precisely 22 times the sine of 40 degrees all over sine of 43 degrees. Okay? But of course, typically we want to get the actual value here. Okay? And so how do we go about getting this value? What do we got to do? Use your calculator, that's right. Okay, so let's see here. We want to make sure we type this in accurately into our calculator. So let's see here, 22 sine of 40 divided by sine of 43. Okay. So it might be helpful, actually I'm sorry, I'm blocking something, there you go. To put some parentheses around your numerator there. So maybe parenthesis 22 sine of 40 divided by, and then parentheses on the denominator. Not a bad idea. It's not necessary, but it's not a bad idea here. Okay, so we type that in, and we get negative 19.707. Oh, right. We got to make sure we're in the right mode. Degrees. Oh, that makes more sense. 20.735. Okay. I know I make a lot of mistakes by accident. This one was on purpose, but anyway. You can choose to believe that or not if you want, I guess. But so 20.735, okay, is the answer there. Which also makes sense, right? A negative 19 would definitely not make any sense there, because that would be supposed to be a side of our right triangle, or side of our triangle, not right triangle. Okay, great. So now we know that A is approximately 20.735. Well, we can just use Pythagorean Theorem then. We got two legs, and we can just find this hypotenuse, right? So 22 squared plus 20.735 squared equals c squared. Oh, shoot, it's not a right triangle. All right, yeah, so don't use Pythagorean Theorem. Only works for right triangles, okay? Please don't use Pythagorean Theorem here. That is not right. So then how do we go about solving for that third missing side? Same thing with law of sines again. That's exactly right. So we're going to say now sine of 97 over c. Okay, and you now have a choice. You have two pairs of opposite sides and angles that you know, or sides and angles and opposite sides that you know. So we use the 40 over the sine of sine of 40 over 20.735, or sine of 43 over 22. My recommendation: use the piece of information that you used in the original problem. So go back to the sine of 43 over 22. Why? Because if you made a mistake calculating 20.735, you're going to carry that mistake through and mess up your side C. So use the original piece of information that you used there. So sine 43 over 22. And again, cross multiply and solve here. And we'll end up with C is equal to 22 sine of 97 over sine of 43. Okay, and I skipped a bunch of steps there, but there it is. And again, type this carefully into your calculator. Make sure you close parentheses on those trig functions too, otherwise that'll mess you up as well. So 32.018. Okay. That's the other missing side there. Okay. We can also kind of convince ourselves that these are at least reasonable based on that triangle inequality theorem, which you may not remember the name, but you may remember the principle of it. The idea in a triangle is that the smallest angle should be opposite the smallest side. Is that true in our case? Yeah, okay, it is. And is the medium-sized angle, so the next angle up is 43, and that's opposite the next side length up, 22. And then 97 is the biggest angle, and it's opposite the biggest side of 32.018. So it makes sense. It fits that triangle inequality theorem, so that's good. Okay, questions on any of that? All right. So in this scenario right here, okay, the piece of information that we ended up with, we had an angle, a side, and an angle, right? Angle, side, angle. If you guys remember from geometry, is angle, side, angle a congruence theorem? That gets messy, so don't do that, okay? So yes, it does, all right? Yes, it does. So angle, side, angle. So that means we're guaranteed a unique triangle here, right? We're guaranteed a unique triangle, okay, by that angle, side, angle theorem. Don't worry, there's no proofs though, Devin, all right? There's no proofs. Is that what you were preparing yourself for? Okay. Not okay with proofs? You like proofs?
No one likes proofs.
No one likes proofs? Yeah. Less actual math? Well, it depends, I guess, on what your definition of actual math is. Some people might say that proofs are actual math, and all this other stuff is just junk. I mean, they're not junk, but it's just kind of like, you know, all this stuff had to be proved at some point. You know, what people would say is the fundamental math, is making sure it's proved and stuff. All right, let's solve the triangle. Another one. Okay, so again, we solve the triangle. That's finding all the sides, all of the angles. Okay. And again, I'm going to do my best. Oh gosh, this is not being drawn to scale. I apologize. Oh well. All right, believe it or not, this is going to be, well, we'll get to that, never mind. 32 degrees here, 28 degrees here. All right, and then 25, and we'll say feet here, just throwing some units. Why not? Okay, that is not drawn to scale. Ah, well. Okay, so this is another angle side angle. So we're guaranteed a unique triangle here. We're guaranteed a unique triangle here. Okay. So how, I'm not going to ask this, I'm not going to ask how should we start, I'm going to ask how must we start here. What piece must we solve for right off the bat here? Yeah, right? Angle A. Yes, angle A, exactly right. Again, part of that is because in law of sines you really want to start with an angle and opposite side that you know. We don't have that in this case. We have an angle 28, but not its opposite side. We have angle 32, but not its opposite side. We have a side A, but it's not opposite angle that we know, but we can find it, right? So Brian, how are we going to do that? Subtract 32 and 20. That's right, okay? Supplementary. And so when we do that, we end up with 120 degrees, and this is, like I said, not drawn to scale there, okay? This kind of not drawn to scale. All right. So again, now we'll start here. We'll start with the sine of 120 degrees over 25. Okay. By the way, what is the sine of 120 degrees? It's root 3 over 2. That's right. It's 60 degrees. That is 2 pi over 3 right there. It's 2 pi over 3. So it's root 3 over 2. So you could technically do this specific ratio precisely, except once I put in this other one, and I'll know. Let's solve for side C, I guess, here. So sine of 32. And now at this point, you can no longer do it mentally. Because, sine of 32, what is that? Who knows? Okay. So don't fret. I'm not going to be making you do, this very mentally, because it's, well, you can see it's just going to be impossible to do mentally with this problem. Okay, so again, we cross multiply and solve. We can see is exactly 25 sine of 32 degrees over the sine of 120. And we can say that that's approximately 16 point, whoops, I typed in 35 instead of 32. My bad. 16.297. So there's that. So again, approximately 16.297. And we set up just one more law of sine here to find that other side. So again, start back with the sine of 120 over the sine or over 25. Because again, that was the given information. Least likely to have made a mistake there. And then we'll do sine of 28 over our unknown. We'll say that's little b. And so little b is equal to 25 sine of 28 degrees over sine of 120 degrees. Or approximately so about 13.552. Okay. So questions on any of that? All right. Have you guys try one here? All right, so you guys are going to try this one here. All right, so we're going to solve the triangle ABC, that has the given measures. Okay, so the measure of angle C, we're going to say is 108 degrees. Okay, side C is 56 meters, and side B is 27 meters. And I didn't do a very good job here. I should have labeled my other sides up here as in feet, because the triangle is in feet, so my apologies. I should put labels there. Anyway, there we go. Okay, so what I would like you to do first is, let's just make sure we're all on the same page. Just go ahead and draw this picture. Okay, draw this picture. So I have taken made this a little bit more difficult for you, because you actually got to like draw an accurate representation, or draw the picture and label things accurately. So go ahead, draw this. Okay, go ahead and draw this. Set this up. Okay, and don't worry about trying to draw it to scale if you don't want to. Just make sure everything's labeled accurately. You can draw the same triangle every time if you want to. But at least just draw it. Okay, just draw it first here. Okay, so let's look at this triangle here. I actually did try and draw this somewhat accurately, but all right. So I'll say that's C, and that's going to be 108 degrees. Okay, and then let's see. Opposite side C is 56, and then opposite side I'll say that's B, and that's A there. So opposite side B we'll say is 27. Okay, now what kind of triangle congruence do we have here? What kind of triangle congruence do we have here?
Angle side side.
Angle side side. Oh, Mr. Wynn, that's a bad word. Is that a triangle congruence? No, it's not. Uh-oh. What does this mean? Okay, what does it mean? Okay, so it means here that we don't necessarily have a unique triangle.
What does that mean?
That means that this is what is known as the ambiguous case for the law of signs. All right, so what this means is that we actually could have two triangles that match this description. We could have one triangle that matches this description, or this set of information could be impossible and result in no triangle. Okay, so let's go through this as we normally should. So what should be our setup here? How should we set this up? Where should we start? Yep, sine of 108 over 56. Yeah, exactly. Start with the angle and opposite side pair that you know. Unlike the earlier problems that we did, we start with an angle and opposite side pair that we know. And that's going to equal, and then what do we have to set it equal to here?
Sine B over 27.
Exactly. We have to do sine of B over 27. Because that's the only other piece of information that we know. All right. So this is a bit different, right? And the other problems, all we were solving for were sides. Yes, we did solve for angles, but we just used the fact that all the angles in a triangle have to add up to 180. Here, we're going to be solving it using law of sines. So anyway, let's solve here. We'll cross multiply. We get 27 sine of 108 degrees over 58 equals sine of B.
36.
Sorry, thank you. Goodness, that would have been bad. Okay, 56. My apologies. 56. Okay. So now we'll get a decimal here. So let's see here. So it's 27 sine of 108, close parenthesis, divided by 56. And we get something like approximately well, I'll just put this here, 0.459, I guess I'll say, and that's equal to the sine of b. And then how do we solve for just b here? What should we do? Arc sine, yeah, inverse sine, okay? So angle B is sine inverse, and actually I'm going to do sine inverse of the original quantity here that's not rounded. So I'm going to do sine inverse of sine of 108 over 56, like that. Okay, I don't want to use the rounded version because, again, it's inaccurate. I'm going to try and be as accurate as I can here. We'll round after this, though. So 27 sine of 108 divided by 56. And you get about 27.293 degrees. Okay? So that is angle B. Okay. But let's think about, oh, did you need me?
Can I see Brian waiting for just a second?
Sure. Brian?
Where is he?
Right here.
Brian, he's right here. Get your sunglasses when he's back. We didn't sell them. We didn't sell enough to do the order, okay? Sorry, I'm sorry to interrupt.
Nope, no problem.
Have a great day.
No problem. You too. Sorry I didn't sell enough. Okay. So here's where, at this point now is where we kind of can branch off into three different possibilities. So the possibility of there being no triangle that exists is now out the window because we were able to evaluate here. At times when you set up this ambiguous case, again, when you have an angle side-side, or as every geometry book ever calls it, side-side angle, and whenever you have that kind of scenario, when you get to this point when you solve, if you get an error, that means there's no triangle that exists. It's impossible if you get an error. Okay, an impossible situation. Like you get an error in your calculator, so you know that you're done there. No triangle exists. Here, now though, is also where we get to the point where it's like, okay, maybe two triangles could exist though. Definitely one exists because we got an answer, but two triangles could exist. Where does the second triangle come from? How is that possible? Well, remember we take sine inverse of a quantity, okay? So this, when we did this calculation here, it was about 0.459, which is positive, right? Sine is positive in the first quadrant, and so this is that angle in the first quadrant where sine is positive. But sine is also positive in the second quadrant too. And so we also want to figure out the other angle that would result in this positive value. So we're going to do 180, take away that 27.293 degrees, okay? And see if this triangle also works, or sorry, this angle also works. So 180 minus 27.293, and we get 152.707. Okay? Is this a possible angle for our triangle? No, because we already have 108, so 152.707 won't work on our triangle. It's going to make us over 180 already. So how many triangles exist with this information? Just one. Just one. Okay? So that 27.293 is the other one. Okay? All right. We'll do some more with this ambiguous case for the law of sines. It is not within the testing limits of pre-calculus, so it won't show up on a test, okay, or a quiz. But that being said, I still want to present it to you at least because it is a thing that happens. All right. At this point, since we realize there's only one triangle, we would just proceed as normal. We could do 180 now, minus angle C minus angle B, and get the missing angle A. And then you could then find side A by doing another law of sines there. Okay, but we'll just stop here. I want to get you guys time to get started on your assignment. Okay, so yeah, and we can finish that up in set if anyone wants to see it more or anything like that. I can answer any questions you might have too. So let me get you guys started on your assignment then, because I want you to have the opportunity to get started on stuff. Okay. All right. So your homework will be page 434, numbers 5, 9, 21, 25 and 45. Excuse me. So 5 problems. Excuse me. Okay. I'm also going to pass out your next free response, or next problem set too here.
Are we gonna have one every week?
Roughly. Roughly. I think there's 9 total, it looks like.
I thought the 5.
Are there even, there's not even numbers.
You're right.
No.
So why is there nine? There's not 9.
Sometimes we'll do one during class.
Oh.
Sometimes we'll do one during class.
When are we taking the benchmark again?
So what now?
When are we taking the benchmark again?
Benchmark is
April. Wait, is there only one benchmark?
1 month from today.
So 2 first?
Well, there's 2 parts to it, but yes, there's 1 benchmark. So June 1st. You'll be doing before.
So technically we should only have 4 problems.
Well, we're gonna have